Solving quadratic equations by factoring. Well, will the number of answers always be the same when solving a quadratic function, and why? Well, we have to remember what's going on with our parabola. Okay, so if we think about it, we draw ourselves, let me quickly draw 3 coordinate planes very quickly, and think about our parabola. We know that our parabola could be crossing in 2 places. It could be sitting on top of the x-axis, or it could be not touching anything at all. So because of that, we can have either 2 answers, 1 answers, or no solutions. So will the number of answers always be the same? Not necessarily, but you know it's going to be one of these 3 answers. So that kind of narrows it down a little bit. So let's take a look at some things about factoring. First of all, remember that an equation means that it's an equal sign. Now, when we've been talking about factoring, we just looked at this quadratic by itself, just like this, standalone, and factored it. Well, now the only difference is we're going to add this equals 0 because we're solving an equation. We got to remember that that little 2, that exponent of 2, means that there will be possibly be 2 answers. And remember that when we do solve by factoring, a polynomial must equal 0 in order to factor. And the reason that it equals 0 is because that is where we're going to find the roots of the equation. So let's take a look at this. Let's watch this all the way through. So normally we would say, hey, let's take a look at this. We don't know what else is going on. And we would say, we would take the c and multiply it times a, which is 1, put that on top, and put the b on the bottom. We think of 2 numbers that would multiply together to give us -7, add together to give us -6, and that would be -7 and +1. We would use these terms here in the middle from our little diamond. And from this diamond, what we would do is rewrite this middle term. So when we do that over here, we're going to get x squared plus 1x minus 7x minus 7. Now the only thing difference is there's that equals 0. That's what we're going to add right now. So we're just going to add that on there, equals 0. And we're going to take it with us as we go. We're still going to do what we did before about factoring. We're going to take a look, factor out the greatest common factor, leave behind what's there, which is x plus 1, write that binomial on the other side, multiply that binomial times -7, it still equals 0. If we take the common binomial out, which is x plus 1, leave behind the other binomial, which is x minus 7, and we're saying that equals 0. So now let's think about this intuitively. And what do I mean by intuitively? Well, we want to take a look at this and say, what does this really mean? Something times something equals 0. That means that one of these has to equal 0 in order to be true. So what we want to do is use the 0 property. And what that'll allow us to do is to take each of these, x plus 1, and set that equal to 0, and take the other one, x minus 7, and equal to 0. We'll solve the first one and find out that it's -1. We solve the second one, we find out that it is at +7. So let's make sure and see what's going on here. Let's plug this back in and see. If I put a -1 into this first binomial, -1 plus 1 is 0. -1 minus 7 is -8. 0 times -8 is 0. So this indeed is a good solution. Here we have 7. Let's put 7 in. 7 plus 1 is 8. 7 minus 7 is 0. 8 times 0 is indeed 0. So again, we have our 2 solutions. And we should know, noticing that from our original equation here, that we've got an upturned parabola. It's going to be moving around, and our y-intercept is -7. So we know with an upturned parabola with a y-intercept of -7, something's going on, that we're going to be crossing more than likely in 2 places. So this kind of lends us that. And so hopefully everybody can see how that works. And you can list your answers a couple different ways. You can list your answers like this separately. You can say x equals -1, 7, and please do not put parentheses around those numbers because that would mean that it is an ordered pair, which it's not. And the other way that you can do it is you can do it by points. You could say that one of the solutions would be at -1, 0, and the other would be at 7, 0. So that kind of gives you a little bit of mix of things that you can do. So let's take a look at some questions. First off, let's look at this example. X minus 3 times x plus 4 equals 0. Well, since it's already factored, it's saying something times something equals 0. We can take each of these factors separately and set them equal to 0 to find out what that number would be and what we would plug in. In this first instance, we would add 3 and find out then that x equals 3. Over here, we would subtract 4, and then we would find out that x equals 4. And these are our solutions. Let's take it a step further and take a look at another one that's factored. This is y times 3y minus 17. Now, at first, some people may get confused and not realize, but really, this is 3y squared minus 17y equals 0 factored. So this is what was started with the greatest common factor with just a y. So in pulling the y out, there's that y, and what remains is the other factor. So same thing applies, just like we did in example 1. Take the factors, set them equal to 0. So y equals 0, and here 3y minus 17 equals 0. We begin to solve for the second one because the first one's already done for us. We have 3y equals 17. Divide both sides by 3, and we get a fraction of 17/3. So those are our two solutions, or where that graph is going to cross the y-axis, the x-axis down our parabola. Let's take a look at another one here, start to finish. X squared minus 5x plus 6. We're going to use that diamond, and we're going to say 6 times 1, which would be positive 6, goes on the top, and negative 5 goes on the bottom. We would need to multiply two negative numbers to get a positive and add them together to get a negative. We're going to use the numbers 3 and 2. We're going to then rewrite this polynomial to be x squared minus 3x minus 2x plus 6 equals 0. Cut it in half and see what's going on. Greatest common factor of x, leaving behind x minus 3. We'd write x minus 3 on the other side. And again, we would multiply this binomial times negative 2 to get negative 2x plus 6. Set it all equal to 0. The greatest common factor again is x minus 3, leaving behind x minus 2. So here are our two binomials. Set them both equal to 0. So I have x minus 3 equals 0 and x minus 2 equals 0. Solve the first one by adding 3 to both sides. I find out that x equals 3. The second one I'd solve by adding 2 to both sides, and I find out that x equals 2. Let's try this again with this one. X squared plus 4x equals 21. We have to remember what we first started with. It has to equal 0 in order to start factoring. So let's subtract 21 from both sides, and we end up with x squared plus 4x minus 21 equals 0. Again, on top of our diamond, we're going to multiply the a and the c together, giving us negative 21, and on the bottom would be positive 4. In order to get a negative, I need a negative and a positive. The numbers 7 and 3 will work, and those add up to give us positive 4. So we're going to rewrite this term 4x with these terms. So x squared minus 3x plus 7x minus 21 equals 0. I'm going to cut it in half and take a look at it. Greatest common factor on the left side is an x, leaving behind an x minus 3 in the binomial. Writing x minus 3 on the other side, multiplying that times positive 7 will get us the binomial 7x minus 21 equals 0. Again, the greatest common factor is x minus 3, so we're going to pull that out, leaving behind x plus 7. So both binomials equal 0. We're going to take them both, set one equal to 0 and the other one equal to 0. We're going to, first one, add 3 to both sides, find out that x equals 3, and this other one we're going to subtract 7 from both sides and find out x equals negative 7. So this quadratic is going to cross the x-axis at 3 and negative 7. We're going to do one more. Here we have negative 2x squared equals 20x plus 50. Again, it's not in standard form, so we're going to start out by adding 2x squared to both sides. Let's get everything to the same side. So I get 0 equals 2x squared plus 20x plus 50. Now I can start off right away and put the numbers 120 up here, but we can tell that those are really big numbers. That means we haven't found our greatest common factor yet. So when we look at this 2x squared plus 20x plus 50, we know that 2 is the greatest common factor. So let's pull that out, and this will make this smaller, x squared plus 10x plus 25. A little bit more doable. Let's put positive 25 on top, positive 10 on the bottom, and we can see that the factors are identical. Let's rewrite what we have. 0 equals 2 times the quantity of x squared plus 5x plus 5x plus 25. We're going to cut that in half. Take a look at it. Again, as we're looking at things that 0 is coming with us, 0 equals, this 2 is still coming with us as part of it. Greatest common factor is x. Take out x plus 5. Write down x plus 5 on the other side. And multiply that times positive 5. And we see that our two binomials are 2. We got that 2. We're going to have x plus 5. I'm going to use parentheses there. I apologize. X plus 5 times x plus 5. Well, when we take a look at factoring, we don't have to factor the 2 because 0 doesn't equal 2, so that's not going to help us. The only one we have to worry about is this one, so x plus 5 equals 0. We subtract 5 from both sides and find out x equals negative 5. So what is this saying? Why is there exactly the same? Well, remember about our parabolas. Remember we talked about this is probably sitting right here at negative 5, and it's going upwards like this. So there's our one solution. It's sitting there. So when we get identical binomials, when we factor, we know that it's sitting on the x-axis. And that'll be the end of this lecture about solving quadratic functions by factoring.